This video, I'm going to explain how to run some basic descriptive statistics alongside bivariate correlations that are usually needed when you have a study with a correlation on design. The descriptive part can be applicable to any type of study, but the bivariate correlation is always required when you're writing a report based on any type of regression analysis or regression-based type of correlation studies. Um, so in this data set, and also you need some descriptive statistics either for your method section when you provide like demographic information or for your result section when you provide like mean standard deviation or some basic descriptive statistics for your results. So imagine that this data set, we have some demographic information that we can include in our descriptive analysis, like age, gender, marital status. We have four independent variables that here for this analysis actually doesn't matter whether they are dependent or independent, but I have like imagine four independent variable that I call them IV1, 2, 3, 4. And I have like depression as my dependent variable that I have different version of this variable. For example, I have two categorical version, like for example, one is like sort of ordinal, categorical ordinal version that is like mild, normal, severe, or extremely severe. And another one is a categorical binary version of this variable that, for example, is non-clinical versus clinical. And also I have a continuous version of this variable, like just the scores of the participants on depression assessment tool that without categorizing them to any category. So I will explain how you can use different version of this variable in your analysis. So let's start with descriptive statistics that like in SPSS, we can do it in separate parts, but all can be done from this section that is analyze descriptive statistics. So I can use frequencies for my categorical variables. Like for example, for some of my demographic information would be good to come here. So first, let's do it. So I have already actually done it. I can reset it to show it from a snatch. So you can see that like I need to see like for example the percentages of gender for my method section for demographic information in my method section. So and also gender is a categorical variable. Marital status is another categorical variable that I'm interested to see its level. And if I want also to see the information like the percentage of participants in different category of my dependent variable, I can also include this one as well, like to see how many participants I have in, like, for example, severe level of depression, how many participants have normal levels of depression. Also, I can include binary version of my depression variable as well to see how many participants are clinical, have clinical levels of depression, how many of them have normal levels of depression. So you don't need actually to check anything here, just okay. And here, for example, you can see now have frequency and percentages for each levels of your categorical variables. For example, I know that for gender, I know that like, for example, I have this number of female, this number of male, this number of non-binary, and the relevant percentages for that. So these two are the relevant statistics that you report for gender in your method section. For marital status, again, frequency, percentages, and like for depression, that is not a demographic variable, but it's actually one of my key variables that is categorical. If I'm interested, I also can check the frequency and percentages of participants in each levels of my categorical variable. Like for example, I know I can see that 181 participants showed normal levels of depression. That is 50% of my data. And the same for the rest. For binary version of my depression variable. Also, I can see that, for example, 36% have shown clinical levels of depression and 64% have shown non-clinical levels of depression. So this was about categorical variables, how we can see descriptive statistics for them. So definitely mean standard deviation doesn't make sense for categorical variables because that is just a meaningful statistics for continuous variable that which we are going to test now. For descriptive statistics that are not categorical, you either can use this option or explore, but I would recommend using explore because you can also check some assumptions with this option. So if I go to explore, uh, I can, again, I reset that. So here you put all of, because you already have a statistics for your categorical variables. So now here I just test my non-categorical variables, like the continuous variables. That is, all of my IVs are continuous. So I put it here. And also, I remember I said that my dependent variable, which is depression, has three versions. So here also I can put for example, if I want to see the mean of on my depression level as a continuous variable, I can put the continuous version of my dependent variable here as well. If I want to see mean as a standard deviation for the continuous version of my variable as well. And also a few things that we need to tick before running the analysis is this making sure descriptive is checked, and also I can tick outliers. So this can help me for some assumption checks for my inferential statistics. For example, for some type of regression analysis, is one of the assumptions that you shouldn't have outliers, influential outliers. So for that purpose, I can have an initial check here, although it doesn't necessarily show influential outlier, but it's a simple analysis of outliers still. The next one is plot. That stem and leaf actually is not very helpful for your analysis. I'm going to untick that, but instead of that, I tick the normality plus with test, and also I can tick histogram to check the normality of, to check whether the distribution of my data for each variable is normal or not normal. It is not necessarily an assumption for all type of inferential statistics, but it can be for some of them, and including the bivariate correlations. For example, it can inform your decision for the type of bivariate correlation that you want to choose. So that's why I would suggest that you always check the descriptive statistics before checking your bivariate correlations. So I will explain that further later. So continue. And nothing else you need to check here, just can tick OK. And here you can see that for each of your variables, you have plenty of descriptive statistics now, which definitely you don't need to report them all. The essential and conventional types of descriptive statistics that you need to report is a mean, that here is a standard deviation that we can find here, and a maximum and minimum that is also very common to report, that we can report that in your results section. The rest are not very important or very essential to report. And sometimes also based on the skewness correctness, you can also interpret your normality or distribution or not, but there are also some easier way to interpret that. So again, mean a standard deviation and maximum minimum for each of variables that you can check from this table. And the other one statistic that is very important is Shapiro-Wilk statistics to test whether your distribution of data is normal for each variable or not. And you can see you have it for each of your variables. My four IVs and depression, the continuous level version of my DVID, which is this depression total scores. And so what you expect here is that if the Shapiro-Wilk statistic is not significant, that means that your distribution of data is normal. But here is significant for all of my variables. That means that it's less than 0.05. So that means that the normality for all of my variables is violated. So if I have a type of inferential statistic that requires normality of raw data as an assumption, that means that it is violated, and I may need to consider some additional step to interpret those results. And also you can see histogram, you can see QQ plot that also can show the violation of normality, that show that there are some skewness in your data. And another thing that is important here, the last thing that we need to check from your descriptive statistics is outliers that is presented through this box plots for each of your variables. You can see IV1, for example, this is the outliers. And it shows that participant number 71 in my data set is an outlier for this variable. It shows that, for example, these participants, a lot more participants for my IV2 for this variable, like participant number 307, participant number 118, and etc. They are all outliers for this data. And you can check it for each of your variables, like through these plots that you can see here. And for example, here for this variable, I don't have any outlier. That means that, so there is no concern at all for this variable. However, what does it mean? Does it mean that you need to go and remove these participants? Like for example, participant number 318, 29, these are outliers. Should I remove them? Not necessarily. The short answer is that you don't have to necessarily to remove them. Some of the inferential statistics, like some types of regression analysis, can give you some measures to decide, to show that whether these participants are influential outliers or not. Maybe they are outliers for your individual variables, but when you test your regression models, for example, they may not have a significant influence on your regression models. So in that case, some statistics like Cox distance, it can tell you whether you need to remove them or not. That you can check it directly with your inferential statistics, so you don't have to return to this results anymore. However, if your analysis doesn't give you that option, for example, like binary logistic regression, sorry, not binary, the ordinal logistic regression, like for example, doesn't give you that option to check influential outliers. So in that case, you can come back to this result, and then you can decide whether you want to keep the participant on or not. So in that case, you can do what we call sensitivity analysis. That means that I run my inferential statistic, like my regression models, once without excluding any outlier, and see what results I get. Another time, I can filter my data or remove all these outliers from my data that's shown here, like detecting them and filtering them or removing them from another version of my data set. And then I run my inferential analysis again and see if there is any changes in the significance of the results that I get. For example, if everything is similar, not necessarily the same, but similar. For example, all the significant effects is similar across both times that I check my inferential statistic with or without outliers. In that case, I can understand that they are not influential outliers. So I can keep them because they are not affecting my inferential statistics. But if I see that when I remove these outliers from my data set, some of the results that were initially significant are not significant now, or the vice versa. Maybe they were significant, they were not significant, but they are significant now. So then I can understand that these outliers actually were influencing my inferential statistics. And that's a good ground to remove them from my final analysis. So that was all for descriptive statistic. And now, how about the bivariate correlation? So remember, I said that the normality assumption that we checked here through the Shapiro-Wilk could inform your decision for the type of bivariate correlation that you could choose. So for bivariate correlation, again, let me reset that. Bivariate correlation by default is set for Pearson correlation. And usually you can see that almost in all publications, they always report Pearson correlation for bivariate correlations. However, there are some, if you want to have a very strict statistical approach, you would know that one of the assumptions of Pearson correlation is that your distribution of data for the variables should be normal. So in that case, Pearson correlation can give you more precise results. So that's why that if I see extreme violation in this assumption, like you can see here, none of my variables have a normal distribution. So in that case, I may decide to go to a non-parametric or also test a non-parametric version of bivariate correlation alongside Pearson correlation. So I have two options for non-parametric version of Pearson correlation, that is Kendall's test and Spearman test. So Kendall is not applicable to my data because Kendall is when you have very small sample size, but like for example, 50 participants, less than 100 participants. But here I have larger samples, so I have 300 something participants, so like 358 at least participants I have. So in that case, I go to a Spearman correlation. So the good part for a Spearman is that it tests the same thing, like it tests the bivariate correlation, but it's not sensitive to violation of normality assumption. That means that the violation of normality assumption does not affect the result. So here I'm going to test both of them once through Pearson and once through Spearman result. And but also before running uh, the analysis, also explain one point that you usually don't have to necessarily go this extra step and doing a Spearman like test of bivariate correlation. If your purpose of presenting a Pearson correlation is just a descriptive purpose, that means that you are just presenting Pearson correlation to show a descriptive view of the bivariate relationships between your variables. However, you are not using that for hypothesis testing. That means that your hypothesis is going to be tested through a more complex analysis type, like for example, through logistic regression, not necessarily through Pearson correlation. But the purpose that you are using Pearson correlation is just showing a general picture of your the relationship between your variables. So in that case, there are many seminal statistical publications that saying that you don't have to worry about the violation of the assumptions of Pearson correlation. I can right away just report Pearson correlation without additional step to report SPM. But here, just for educational purposes, I'm including both of them. So here for SPMN, what type of variables I need to include? So it's better that actually you and can be more consistent if you include all of your continuous variables for this. I mean, in general, we include all our key variables. Key variables means that all of my IVs, like independent variables, and my DVs, dependent variables. So here, all of my IVs are continuous, which is no problem to be included in Pearson correlation. However, I have three versions of my DV. I have one continuous version and two categorical versions. So which version is better for this analysis? Definitely the continuous version is better and for this analysis because it's consistent with Pearson correlation. So it's consistent with my other variable types that are all continuous. And here I just want to see bivariate correlations. I don't want to do any hypothesis testing. So for that purpose, I don't need to worry about like categorical version of my DV. So I tick Pearson, I tick Spearman, and now let's run the analysis. So